Okay, question number 6, maximum mark 7 points. Consider the function f of x, just like this, where x is real number and x is greater than 0. Show that the distance L between the origin and any points on the graph f is given by this equation. So it says the distance, right? The distance between the origin which is origin which is 0, 0 to any point of the graph. We can define any point of the graph by xy coordinate. Because x is greater than 0, so we can put x coordinate, just put x, and y coordinate is gonna be the f of x. This is any point of the graph, right? So this also can be expressed as x comma x point, y value is which is f of x. It's square root of ln x squared ln of x plus 4 minus x squared, everything inside the root. So okay, question. So distance between these 2 points, we can use a distance formula. So question number 8. So distance L can be defined as the square root of x2 minus x1 square. So we got the x minus 0 square plus y2, this one minus that one squared. So square root of x squared of ln x plus 4 minus x squared minus 0 squared. This is the distance between origin and any point of the graph. So just by simplifying this, we got the square root of first one is x squared, and the second one is just this is cancelled out, right? So we got the x squared of ln of x plus 4 minus x squared, everything inside the root. And this 2 cancels out, and we got square root of x squared of ln of x plus 4. This is the distance L from the origin to the any point of the graph, which is exactly same as what they want. Okay, question number B. Hence, find the x coordinate of the point on the graph of f which is closest to the origin. Okay, B. So this is distance L. So they want us to find x coordinate where L is minimum. So they find the L minimum. This one happens square root of x squared ln of x plus 4. Because inside the root, this one must be greater than 0. Square root of something greater than 0. The minimum value happening when inside the square root becomes a minimum value. So we can find, let's say we can define of g of x equal x squared of ln of x plus 4. We need to find g x goes to the minimum. We need to find the x coordinate where this function goes to the minimum. How do we find this? So we can do the differentiate both sides. So we can get g prime of x. We have to apply the product rule. Differentiate the first one, 2x, put second one, plus leave the first part, x squared. Differentiate the ln x is we got 1 over x. Differentiating 4, you got the 0. So we got here 2x of ln x plus x. So when g prime of x equals 0, we can find local maximum or local minimum. Okay, we can factorize x in front, and 2 of ln of x plus 1 equals 0. Because x is greater than 0, we can just, that this means x equals 0, or x 2 ln of x equal negative 1, which means ln of x equals negative 1 over 2. So x cannot be 0, so the answer should be this one. So x equals e to the negative 1 over 2, which means that 1 over square root of e. This must the point where that the graph, that distance is the minimum. So we can think of, make sure this is a local minimum, we can think of a sign diagram of this one. Because x is greater than 0, x is always positive, so we only can think of that one. So we can put the ln of x over here. So 2 ln x equals 0 is negative 1 over 2, so negative 1 over 2. The graph goes like here, like this, because ln of x, this is pretty much a linear function, and then when x is less than negative 1 over 2, it is negative. As x is greater than negative 1 over 2 is positive. So when negative to positive, which means that this point is local minimum, right? So this is local minimum. So this is the answer. Okay, I can show you my answer. Okay, let me show you. This is paper 1, but let me double check my answer if it's correct or not. So we can, all we can do is we can draw a graph of this function. So square root of x squared ln of x plus 4. So we can draw this function. So this is local minimum point, right? So find the corner of the x value. So make sure this, okay. Then what we can do is we can go to this second draw and draw a vertical line. So the answer is 1 over square root 2. So 1 over square root of e, actually, square root of e. So we can draw the vertical line, done, and we see the graph, C. So the line over here is the local minimum point. That is x coordinate, 1 over the square root of e.